Here we go. The next question is, what is the derivative of tangent x? Now, as we learned when we learned all of the trig ratios, the functions, everything is really based on sine of x and cosine of x. You can think of the tangent of x as sine x divided by cos x. We mentioned that before. So we're not going to discover the derivative for tangent x with a graph. That would not be a good way to go about it. Instead, we are going to think of it as sine x divided by cosine of x. And what rule should we apply to this? Well, obviously we're dividing. We're going to use the quotient rule. And we know those derivatives for sine and cosine, so we can go ahead and go for it. Okay, here it is. Quotient rule, of course. I'll just show you the whole thing. I don't know why some of this is like super sharp and other parts are kind of fuzzy on the camera, but it's the way it is, I guess. Quotient rule, we know we do the low times the derivative of high. Well, the high is sine of x, so the derivative high is cosine x, minus the high times the derivative of the low. Well, if the low is cosine of x, then the derivative of low is negative sine x. So there we have low d high minus high d low, all divided by the low squared cosine of x squared. And there's our derivative, but we're going to clean this up. Turns out it cleans up really nicely. Not obvious at this point that it does, but it will. Okay, so I'll just show you this whole thing. Clearly I've got cosine times cosine. That goes to a plus in the middle. Sine times sine. I've got cosine of x squared plus sine of x squared, still divided by the cosine of x squared. And now here's what I'm going to do. It turns out that this numerator is a known we call a trig identity. If you have taken the trig course, then this will probably sound familiar to you. If you haven't taken trig, nothing to worry about. This is not going to come about in any question that we're going to get. Just so happens we need to know how this simplifies in order to write this derivative the way that we need to think of it in the most simplified form. It turns out this numerator, the cosine of x squared plus the sine of x squared for any value of x, this always equals 1. If you don't believe me, try it out in a calculator. Put the same value of x, could be degrees, could be radians, doesn't matter. Put the same number in there, do cosine of that squared plus the sine of that squared, you'll always get 1. Okay, so if that whole thing goes to 1, then of course it's 1 divided by the cosine of x squared. But wait a second, 1 divided by cosine of x. Does that sound familiar? That's the secant of x. So it turns out 1 divided by cosine of x squared is secant of x squared. And then I wrote this again just to kind of cap it off. Turns out the derivative of tangent of x, surprising, yet pretty simple, the secant of x squared. Definitely did not see that coming. But there you go. Okay, at this point, we have deduced the derivative for sine of x, cosine of x, and tangent of x. We're going to stop there. I'm just going to tell you the other 3. Here are all of them. And so I'll give you a moment. We're going to actually talk about these just kind of as a group even. Try and get it nice and lined up. You can see it well enough. That's fine. Okay, so here are the three that we know already. The sine of x, derivative sine x is cos x. Derivative of cosine of x is negative sine x. If I point the camera straight down, that'll be a little bit. Okay, I think that's a little better. Derivative, okay, we know that. Derivative of tangent x is secant x squared. And the other three have a little bit more going on, but we're going to try and make this easy to remember. The cosine of x derivative is, oh, excuse me, cosine. Cosecant of x, derivative cosecant x, negative cosecant x, cotangent x. Derivative of secant x, tangent x. And derivative of cotangent x, negative cosecant x squared. So let's kind of take a step back and look at all of these. Let me cover that up. We'll just look at all of these together and we'll start to see some patterns. First thing you notice is what's negative and what's positive. Which ones are the negatives? And most people think of this as, well, it's all the ones that start with co. Cosine has a negative derivative. Cosecant, cotangent. And all the ones that are not the cos have a positive derivative. And so that's a good way to remember it. If it's a co, you know that derivative is going to be negative. Okay, so that's nice, but there's a lot more going on than that. Here's how I like to think of it. I don't know if most people do this, but I think of certain pairings. I think probably most people think of the pairings, but I think of them as being like friendships. So sine and cosine are friends, right? The derivative of sine is cosine. The derivative of cosine is negative sine, and I can remember that it's negative because it's a co. Another pair of friends are tangent and secant. The derivative of tangent x is secant x squared. The derivative of secant is secant x tangent x. Each one involves its friend. It turns out secant x has itself as part of the derivative as well. And then we know that that's squared. Also, cosecant x is friends with cotangent x in a similar way. Okay, so there's this really clear similarity between the derivative of tangent x and cotangent x, right? So if we just remember maybe this one, the derivative of tangent is secant x squared, we can easily remember this if we remember the negative and the friendship. Well, if derivative tangent x is secant x squared, then the derivative cotangent x, well, it's its friend squared, and it's a co, so we put a negative in front of the whole thing. Something similar between cosecant and secant, right? They have a similar pattern. They both have themself and their friend. So cosecant has itself and its friend, and we know it's negative. Secant has itself and its friend. So maybe the only one you actually bother remembering, and this is what most people do, they just remember that the derivative of secant x is secant x tangent x. And then if they're ever asked about cosecant x, oh, it follows the same pattern. It's itself and its friend, and well, it's a co, so I know it needs a negative. That's how I would recommend remembering these. On the other hand, you know, you're going to be doing several homework problems. Maybe they just start to stick because you do several homework problems. And then we're going to do antiderivatives, in 8.4. That said, we're really not going to do many problems with these. And we'll see how much they come up in the future, in future chapters. They might be rare enough where we really do just need to remember these friendships and the negatives and that sort of thing. It might not be that we end up repeating them so much that we just memorize it that way. But I think this is a At first it seems pretty intimidating to remember all these 6, but when you start to see these patterns, makes it a lot easier. Okay, okay. Enough about all that. Let's wrap this up with a couple of more examples. I just got 2 more. So this is part D of that same example to differentiate. Let's go with y equals the tangent of 3x squared plus 1. Okay, so we've got a chain rule, of course. A lot of chain rules with these, pretty common. I'll start with my derivative of tangent. I know the derivative of tangent is secant x squared. So let's just go for that. I'll just show you the whole thing. So I've got the secant squared, and what goes inside, of course, is the same inside that I had before. So there's my secant squared, but then I copy that part at this step. Then I need to multiply by the derivative of my inside. Well, that's 6x. So there I have it. I'd probably want to write this with the 6x in front. Looks a little bit nicer that way. So there's my final answer, 6x times the secant of 3x squared plus 1, all of that squared. There you go. All right, I just got one more. Really, your homework, when you see the 8.3 homework, it's just going to be primarily, all with the exception of all but 1 or 2 problems maybe, take a derivative. Just they're going to throw a trig function combined somehow. A lot of chain rules, but there's some other, some quotient rules and that sort of stuff in there. Okay. Last one, f of x equals x cosecant x. And as you look at this, what familiar rule will apply? Well, if we've got x multiplied with cosecant x, that is a product. We're multiplying these 2 things, right? So when we do our derivative, we're going to need the product rule. And I'm just going to go ahead and show it to you. Of course, if we were in class, we'd be talking about this step by step, but not here. All right, so our derivative, well, derivative of x is 1 times cosecant x plus we've got the x that we just copied multiplied with the derivative of cosecant x. It's itself and its friend, and it's a co, so we know it's negative. Let's clean this up just a little bit for our final answer. Not really much to do. Get rid of the times 1, move the negative out here to make it a minus. There it is, f prime of x equals cosecant of x minus x cosecant x cotangent x. Quite a derivative there. Okay. That is it. That's 8.3. Check out the homework.